In today's lesson, we're going to start studying trigonometry. So trigonometry is really just the study of relationships in right triangles. And if we actually go back to, the Greek word trigonometry, it's kind of derived from the idea of triangle and measure. And so we're going to be focusing on the measures that we could have for, right triangles and what kind of relationships are happening in there. And we're going to spend a few days on this. This first lesson, all we're going to focus on is how to write the relationships, technically the ratio equations that we're going to need to solve these triangle problems later on. And so we'll be looking at that in our next two lessons. Today really is just about writing the ratios. And there are a couple symbols that you might see me use, or they may be, in depending on what resource I get my diagrams from. And these are actually Greek letters. And they're another symbol that we could use to stand for the angles in a triangle if needed. I think most of what we're going to look at today is going to use the letter of that vertex in our triangle, but you might see these three Greek letters. The first looks like a circle with a cross through it, or a O with a cross through it, and that's technically called theta. Okay, that lowercase a looking thing is alpha, and that fancy B is called beta. And you might see other Greek letters used in, future math classes or in science class to stand for constants as well. And it just gives us another variable to use instead of X or Y. All right, so trigonometry, we have multiple things that we can study, but when we're looking at right triangles specifically right now, we're going to be looking at three main ratios. And when you study trigonometry in any future math classes, everything is based off of these three ratios. There are three ratios are called sine, cosine, and tangent. And these just represent the ratio that we can write in or with the sides in a triangle compared to what kind of our reference angle is going to be. So for sine, we're going to be looking at the side that's opposite an angle versus the length of the hypotenuse of that right triangle. And we abbreviate this as sine theta equals opposite over hypotenuse, because it takes a while to write out those words. And this will mean more when we look at our diagram right below and start writing these equations out. Cosine is when we're looking at the side that's adjacent to whatever angle we're referencing over the hypotenuse of our triangle. And we can abbreviate this as, cos, standing for cosine, of theta equals adjacent over the hypotenuse. And our third ratio is the tangent. So tangent of our angle technically is the side that's opposite that angle over the side that's adjacent from that angle. And we can abbreviate that as tan theta equals opposite over adjacent. So let's look at example one and start filling in some actual values to write equations. So we're going to use the segment names on here. So again, it might help to label. We have segment AC, we have segment BC or CB, either one would be fine. And then we have our hypotenuse segment AB. And so let's just write out ratios with these values. So sine A, again, is our opposite side divided by our hypotenuse. So the side that's opposite from angle A, well, that's side BC, straight across from the triangle, or from that angle in the triangle. Cosine of angle A, well, that's going to be the adjacent side. Well, BC is opposite. Which one's adjacent? That's not the hypotenuse. Well, that side AC. Oops, excuse me, I need to finish my sine ratio, don't I? So my hypotenuse was AB. So cosine is adjacent over hypotenuse. And so our adjacent side is AC, whereas our hypotenuse is still AB. Okay, tangent is opposite over adjacent. So the opposite side to angle A is still side BC. The adjacent side is AC. Okay, so let's do this again, but from the perspective of angle B. So I'm actually going to change my color, change over to red. And so now again, I want to make sure that I know which side is opposite, which side is adjacent. So a lot of times I'll actually circle my angle in the triangle. And if I draw an arrow straight across, that helps me identify the opposite, and that can help get me started. So now if we're looking at angle B, well, our opposite side is AC. The hypotenuse is still AB. Wait a second. That's the same ratio that we did for cosine of A. Interesting. Let's see, cosine of B, adjacent over opposite. Well, the adjacent side to angle B, that's not the hypotenuse. Well, that's side BC, and the hypotenuse is AB. Wait a second. That's what sine of A was. Interesting. Okay, tangent of B, again, opposite side is AC. Adjacent side is BC. Wait a second. That's the reciprocal of tangent of A. Why do you think that's happening? Okay. Let's see what happens, when we do another example on this. Of course, before we go to that next example, you'll notice there's a note on here that says we're not going to be using these ratios in terms of our right angle. So in terms of the 90-degree angle, here's the reason why. So if we're trying to figure out what side is opposite, what side is adjacent, and what side is the hypotenuse, and they all have to be 3 different sides, well, if I looked at angle C, the side that's opposite that is, well, that's side AB, that's the hypotenuse. But how could it be the opposite and the hypotenuse? That doesn't make any sense. And there are other ideas that you'll fold into that if you go into higher mathematics and start studying trigonometry in either Algebra 3 with trigonometry or pre-calc, and definitely revisited in calculus. So in higher math classes, you'll look a little bit more in depth as to why we don't tend to use that, or we have a separate set of rules that works with finding those ratios for 90 degrees. Right now, all we care about are those acute angles that are going to be in our right triangle. So the angles besides the 90 degrees. So let's see what this looks like when we start putting some numbers in. So here we go. So we're going to do the same thing, but now our triangle ABC has some sides. So side AC is 16, side BC is 30, and side AB is 34. And again, my 34, that's my hypotenuse, so it's not a bad thing to go ahead and mark that down. So no matter what, that's going to be the hypotenuse no matter what ratio I'm writing. Okay, so 2, 3, and 4 are all dealing with angle A. So angle A, my opposite side is 30. So now I can start writing. So sine of A is opposite over hypotenuse. That means 30 over 34. But 30 over 34, can't I reduce that down a bit? Yeah, both of those are divisible by 2, so I could actually reduce the fraction down to 15 over 17. Okay, cosine, adjacent over hypotenuse. What's our adjacent side? 16. Hypotenuse is still 34, and again, both of those are even numbers, so reducing that down, I get 8 over 17. Tangent, opposite over adjacent. So opposite side was 30. Adjacent side was 16. And if I reduce that down, I'm looking at 15 over 8. Do those numbers look familiar to you by chance? If you remember, towards the end of the video last class, we looked at some Pythagorean triples, and one of those triples was 8, 15, 17. So it's going to keep coming back. Anytime we're looking at right triangles, that pattern could, be used in that shape. Alrighty, so let's switch perspectives. So I'm going to switch colors. Let's go to red. And so now we're looking at angle B. And so the opposite side to angle B is 16. So let's start there. Sine of angle B is 16 opposite over hypotenuse, which is still 34. That will never change. And it's the same exact fraction as cosine of A. Okay, if I reduce it down, I get my 8 over 17. And looky there, those guys are the same fractions. They came out with the same value. See, cosine of B, again, adjacent over hypotenuse. So my adjacent is 30. Hypotenuse is 34. Reduce that down, 15 over 17. And again, exactly the same fraction as in number 2 sine of A. And this is always going to happen in any of our triangles. If you change your perspective and you change which sides you're putting in your ratio, well, you're going to see some repeats happening if you kind of switch your angles and you switch which ratio, cosine or sine, you're looking at. Same sort of thing happens with tangent, but a little different. Tangent, again, opposite over adjacent. Opposite from angle B is 16. Adjacent is 30. Reduce that down, that's 8 over 15. Those guys are reciprocals of each other. So it's not a relationship we're going to use that much in this class, but that will definitely be important in Algebra 3 Trig and Pre-Calc. And so that is a big pattern, and that's something that you definitely want to kind of file away and keep an eye out for. And in fact, I can actually use that to predict some values, in a slightly different fashion. So a few more examples. So the idea is, if we're looking at a right triangle, we know we have a 90-degree angle already. So what does that mean the other two angles are always going to have to add up to if all of our angles always add to 180? Well, that means my other two acute angles, well, they're going to have to add to 90 every single time. Otherwise, our angles don't make sense in a triangle. So because the angles in a triangle always add to 180 degrees, those two acute angles are always going to add to 90, which we could also call complementary. And so we'll have that pattern happening every single time, that the sine and cosine, if I flip which angle I'm looking at, I'm also going to flip which fraction goes with what. So we can actually use that to predict something with values, not even having that triangle. So in number 8, 9, and 10, I'm going to look at this even without a triangle. So if I have sine of 30 degrees, well, mentally, if you think about it, if one angle is 30 degrees, what does the other angle have to be? Well, if everything adds up to 180, or you're looking at your complementary angle, well, that's going to have to be 60 degrees. And so if we started filling out those ratios, we would find that sine of 30 degrees always equals cosine of 60 degrees. So if I have cosine of 62, what should the angle be to make it match up with the sine value? Well, what's your complementary angle of 62? So 90 minus 62. 90 minus 62, that gives us 28. So in other words, sine of 28 degrees is always going to be the same as cosine of 62 degrees. And so what about number 10? So if I'm giving an angle of 80 degrees, that means my complementary angle has to be 10 degrees. And if I started with sine, that means I'm matching up with the cosine. And you'll notice all three of these, I'm using these 3-letter abbreviations. If you have a TI calculator, or you're looking at any scientific calculator, to be honest, or you're using a Desmos calculator, again, if you look closely at the things, I know you can't really see them in the video, but you've got a 3-letter abbreviation, and that happens too on Desmos calculator as well. And I'll show you how to use those in our next couple videos. I'm definitely going to concentrate on using the Desmos calculator, since that's what we can embed in any of our practice problems, as well as if you have to take the SOL, that's the calculator that's available. Okay, so the last piece is, how are you going to remember these 3 ratios? And so it's really only 3 things to memorize, but we do have a couple mnemonics. The reminder for sine is always going to be, technically I should fix this, and I'll put this in the printed version. Sine of our angle is always going to be opposite over hypotenuse. And so if you look at the first letters, sine is opposite over hypotenuse. Cosine of an angle is adjacent over hypotenuse. So cosine is adjacent over hypotenuse. And tangent of an angle is opposite over adjacent, or tangent is opposite over adjacent. So if you have any older siblings that have already taken geometry and or algebra 3 trig or pre-calc, you might have heard them kind of muttering SOHCAHTOA under their breath. And so a couple different ways to remember this. Just if you can remember SOHCAHTOA and the abbreviation, it tells you what your letters are and what your sides are. Your sine is always going to be the opposite over the hypotenuse. Cosine is always adjacent over hypotenuse, and tangent is always opposite over adjacent. So if I'm writing this on my paper in the margin to remember, I'm always writing it top to down because that puts the fractions in the correct order. Okay, another way that you could remember this, and you're going to want to listen closely because I'm not going to write this down. The way I remembered how to learn this in my course, in my geometry class, is some old hippie came a hopping, tripping on acid. But of course, that's not really appropriate for school. So the one I'm going to suggest you write down to help you remember is going to be some old horses chew apples happily throughout old age. And it's the same sort of thing. Feel free to come up with your own rhyme, but it's still using the first letter from each of the words in writing out that ratio, and perhaps that will help you remember what those ratios are. And so in your practice today, again, just a graded practice, there's no lesson check. Feel free to try it as many times as you want, but do maximize your score because that's the score that I'm going to put in for your graded item today. And it's all going to be about just identifying the fractions or maybe simplifying the ratios like we did, or perhaps a couple problems where you have to state, if sine equals 30 degrees, then cosine equals 60 degrees. So try out your practice or pop back into Zoom if you need another quick explanation on this, and we will continue practicing this next lesson. Have a great day.